Alright, so now I'm going to go over the skills practice for 7.5 exponential functions. So 1, 2, and 3 we actually already did together in class, but I'm just going to go through these in case anyone missed it or if you just need a review. So for this first set, we're determining whether the set of data shown display exponential behavior, and then we're going to explain. So we're always going to start by looking at the x values and trying to determine if there's a pattern there. They should be increasing or decreasing at regular intervals. So if I look at this first one, it's 0, 1, 2, 3. So obviously we have a regular interval from 0 to 1 is plus 1, 1 to 2 is plus 1, 2 to 3 is plus 1. So these are changing at regular intervals. We always need to check that first so that we can see if there is a relationship with the y values. So now I'm going to look at my y values and see what, if anything, is happening between them. So I've got 5, 10, 15, 20. Well, that sounds like a 5 skip counting pattern. So from 5 to 10, that's a plus 5. 10 to 15 is plus 5, and 15 to 20 is plus 5. So since we are adding 5 between each of these y values, what's happening here is that we have a constant rate of change. Our change in y is 5, and our change in x is 1. So what we have is we have a slope of 5 over 1, or 5. So this is a linear function with a slope of 5. So it's going to be just going straight up like this, pretty steep. So we've got a line here. So no, this actually is not exponential. It's linear. And that's because it has a constant rate of change. And I could be really specific and say that the slope m equals 5. All right, so number 2, we're going to start with the x values once again and make sure that we have that we're increasing or decreasing at a constant rate here. So negative 1 to 1, that's a plus 2. From 1 to 3, that's a plus 2. And from 3 to 5, that's also plus 2. So the x values look good. So now we can pay attention to what's going on with the y values. So I first have 32. And then 16, and then 8, and then 4. So these are definitely decreasing, but to get from 32 to 16, I'm doing minus 16, and then to get from 16 to 8, I'm not doing minus 16. Instead, what it looks like is happening here is that my number is being cut in half each time, or divided by 2. But remember, we want to think about this in terms of a common factor, so we actually want to think about what could I multiply this by. And what we're going to multiply by is 1/2. When I multiply something by 1/2, I'm essentially dividing it by 2. So 16 times 1/2 is 8, and 8 times 1/2 is 4. So here, all of our y values have a common factor of 1/2, while our x values are increasing at a constant rate of 2. So yes, this is exponential. Yes, it's exponential. Because as x increases by 2, and that's a constant rate, by 2, y values have a common factor of 1/2. Okay, so the x values are increasing by 2, and the y values have a common factor, meaning we're multiplying them by 1/2. So this is exponential. And we could go further and say my y values, they're getting smaller and smaller, so this is exponential decay. It's going to look something like this. And looking at number 3, we're first going to check our x values. I've got a negative 5, 0, 5, 10. These seem to be increasing by 5, and they are all the same, so that's good. So now I can check on my y values. I've got 1, 0.5, 0.25, and 0.125. So if you're not very familiar with decimals or patterns within decimals, if you want to think about this in terms of fractions, 0.5 is a half, 0.25 is 1/4, and 0.125 is 1/8. So we're obviously not just subtracting a half, because 1/2 minus 1/2 would give me 0, but these numbers are getting smaller and smaller and smaller. And what we're actually doing here is we are dividing by 2, or we're multiplying by 1/2. So 1 times 1/2 is 1/2. 1/2 times a half is 1/4. And then 1/4 times a half, whoops, I wrote that wrong. We are multiplying by 1/2, we're cutting it in half. And 1/4 times 1/2 is 1/8. So once again, we have a common factor here of 1/2. We're multiplying by a half every time. So this is exponential. Yes, it's exponential because as x increases by 5 in this case, y values, they once again have a common factor of 1/2. So we have a common factor here. So once again, they're getting smaller and smaller, so this is going down. It's exponential decay. So now we're going to look at graphing some of these functions. So the first one, we have y equals 0.3 to the x. So we can already imagine what this is going to look like. 0.3 is between 0 and 1, so I know that this is going to be exponential decay. And so we're going to pick some values, -2, -1, 0, 1, and 2. We're going to be plugging those in for x, and we're going to see what we get for y. So when I plug in, I'm going to have 0.3 raised to the -2. It's going to be good for you to use a calculator here, and sorry if this is sideways, but I have 0.3 raised to the -2. So if you have your on-screen calculator, we have 0.3 raised to the -2, and that equals, oh, whoops, what did I do wrong? Let's try this. 0.3 to the, oh, I think I used a minus instead of a negative. 0.3 to the -2 is 1.1111. We can do math, enter, enter. That's 100 over 9. For me, I would rather think of this as 11.1 because that's going to be easier for me to graph. So that's what I'm going to do, 11.1. And the original is in a fraction form, or in a decimal form as well. So 11.1. All right, next we have 0.3 raised to the -1. So 0.3 to the -1. So I'm going to clear this, and I have 0.3 to the -1, and I get 3.3333. So I'm going to say 3.3. Then I have 0.3 to the 0. Anything to the 0 is 1. I have 0.3 to the 1. Anything raised to the first power is itself, so 0.3. And I have 0.3 raised to the second power. I'll go ahead and plug that in. And that's 0.09. 0.09. So now I'm going to plot these points. So I have -2, 11.1. So if I go -2, I need to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm actually up off the graph. So at 11.1, I'm about here. And then at -1, I'm going to go up -1, 3.3. -1, 1, 2, 3.3, a little over 3. And I have 0, 1. 0, 1, and then I have 1, 0.3, so 1.3 is just right above that line, and then 2, 0.09, which is just barely. So obviously this is decreasing actually very rapidly, and although it's getting super, super, super close to this x-axis, it's never actually going to touch that line down there. That we have an asymptote there, so this is going to get forever closer to this line at y equals 0, but it's never going to touch that line. So we want to keep that in mind. So now we can answer these questions. This is decay. It's getting smaller and smaller. The domain, those are the x values, are all real numbers. Any x value is possible. We can plug in any number we want for x, and it'll be fine. But the range, the y values, that's not the case. If we look up and up and up, this will keep going up and up and up forever, but as we go down, it's leveling off right here, and it's never going to touch that line y equals 0. So the range has to be, y has to be bigger than 0. It's not going to drop below this line here. The y-intercept, where it crosses the axis, is right, change color, right here at 0, 2. So I have 0, 2, and my asymptote is y equals 0. It's never going to cross that line. Okay, so let's take a look at the next one. Here I have y equals 3x plus 1. So this is a different example. We have a plus 1 on the end. So I'm going to use my same values, -2, -1, 0, 1, and 2. And this time I'm going to plug in, I'm going to do the same thing. I'm going to plug it in for x, but I'm going to add a 1 at the end. So here I have 3 to the -2 plus 1. Let's see what that equals. So 3 to the -2, what that means is I'm going to drop that 3 squared to the denominator, and then I'm going to add 1. So I'll go ahead and show that on my calculator. I have 3 to the -2, enter, plus 1, enter. So that's 1.1. So 1.1. All right, now I have 3 to the -1 plus 1. So let's check that out. 3 to the -1, enter, plus 1, enter. That's 1.3. And then anything to the 0, so 3 to the 0 plus 1 is 1, so 1 plus 1 is 2. And then I have 3 to the 1 plus 1. Well, 3 to the 1 is 3 plus 1 is 4. And then I have 3 squared plus 1. 3 squared is 9 plus 1 is 10. So I'm ready to graph these points. So my first one is -2, 1.1. -2, 1.1 is just right there. My next point is -1, 1.3. -1, 1.3 is just barely higher than that one. Then I have 0, 2. 0, 2. You know what? I messed this up. Sorry, I didn't pay attention to my scale. I'm going to go back real quick. -2, and then 1. This is a 2 here, so 1.1. I hope I didn't do that before as well. I might have messed that up on my first graph. Let me see. Here I had -2. It looks like this is a 1. So -2, comma, yeah, this is counting by 2s. Here's what we're going to do. We don't really need a scale of that. I think that's a little confusing. We're going to just pretend this is a scale of 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. 10, 11. And then over here, same thing. I'm just going to do a scale of 1, 2, 3, 4, 5, 6, 7, 8, etc. Okay, I think that'll work better anyway. We'll be able to see it a little better. So I do have the point -2, 1.1, -1, 1.3, 0, 2, and then I have the point 1, 4, 1, 1, 2, 3, 4, and then I have the point 2, 10, so 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 would be up here. So here we go. Our graph is going up, 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 and as I go from left to right, this graph is going to keep going up forever. But as you can see, this graph has actually been shifted up because of this +1. So instead of having an asymptote at y equals 0, I now have an asymptote at y equals 1 right here. So this graph is never going to touch this line, y equals 1, that's my asymptote. So now we can answer the questions about this one. So this graph is going up, so it's exponential growth. The domain, that means all the x values. Obviously it's going from, we can plug in any value we want, so it's all real numbers. The range, which is the y values, that's not the case. But here, it's shifted up 1 because of this +1 right here. I cannot be anywhere down here. The graph is never going to go down there. So my range has to be greater than 1. And then my y-intercept, which is where I cross the y-axis, is right here at the point 0, 2. And my asymptote is right here at y equals 1. Okay, so we're going to do one more. This is our last one for skills. So we have y equals 1/3 to the x plus 1. So based on the example we just did, actually the past two examples, we can kind of figure out what this is going to look like. We notice that this plus 1 on the end means it's going to shift our graph up 1. And when we have a number that's less than 1, it means that we're going to have exponential decay. It's going to be going down. So that's just a prediction of what this is going to look like. So once again, I'm going to plug in -2, -1, 0, 1, and 2. And I'm plugging it now into, I'm going to do 1/3, use parentheses, to the -2 plus 1. And I'll use my calculator. So use parentheses on your 1/3. So 1/3 raised to the -2. And then I'm going to add 1 to that, and I get 10. So this equals 10. And then I have 1/3 to the -1 plus 1. I'm going to plug that in, use parentheses. 1/3 to the -1 is 3 plus 1 is 4. Then I have 1/3 raised to the 0 plus 1. Anything to the 0 is 1. 1 plus 1 is 2. And then I have 1/3 to the 1 plus 1. So 1/3 to the first power is itself. So, and then plus 1, I think I'm going to have 1.3. Double check that. So 1/3 to the first power, that's, 0.3 plus 1 is 1.3. And then I have 1/3 squared plus 1. That's going to cause me to have 1/9 plus 1, but we'll plug that in over here. 1/3 squared plus 1 is 1.1. I think it's easier to work in decimals, even though original here was a fraction. I think it's easier to work with decimals just because we're graphing, and we want to be able to put these numbers in the right spot on the graph. So once again, here I'm going to pay attention to the scale of this graph because it does count by twos. It's 2, 4, 6, 8, 10, 12, 14, 16. So I'm going to pay attention to that this time. So my first point is -2, 10. So, and over here I'm counting, on my x-axis I'm counting 1, 2, 3, -1, 2, 3. So I'm at -2, 10, which would be here. -1, 4, 0, 2, 1, 1.3, so 1 is here, halfway, and then 2, 1.1. So once again, we're going to continue to have 1 point something forever and ever and ever. Because of this plus 1, our graph is shifted up, and we have an asymptote at 1, which is like right here. So this graph is going to continue getting gradually like closer and closer and closer to that line, but it's never actually going to touch it. We're just going to continue having 1 point something, 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 and it's going to get very, very close to 0, but it's never going to reach 0 actually. So this is what our curve looks like. Our prediction was correct. It is going down, so this is exponential decay. Our domain, which are the x values, they can be whatever we want, so all real numbers. The range, which is the y values, it has to be greater than 1 because of this number right here. The y-intercept is where it crosses the y-axis. That is right here at 0, 2. And you can also look over here and see that 0, 2. And then our asymptote is this line right here, which is y equals, it's horizontal, so y equals 1. All right, and that's